I asked you to do, yeah, so up through 15, let's see, so there's 4, 5, 6, 7, 8. So I asked you to do 8 of the problems. Did that go pretty well? Is that pretty easy?
Yeah, it's 15.
I got 15 was undefined.
Is it really?
Yeah, degenerate hyperbola.
What? It was a degenerate hyperbola. What happened? What was number 15?
It equaled 0.
Oh, the whole thing equaled 0?
Yeah.
Okay. Yeah. Yep, that'll happen. Okay, so let's pick up where we left off. We left off on example 3. This is where you had to complete the square to put it in that graph-friendly form. So remember, there was a whole bunch of stuff to remember about a hyperbola. We had this entire box here that we could go over. Or you could remember a couple quick things. Hyperbolas are graphed just like ellipses are graphed, except for they open out rather than opening in. The hyperbola is open in the direction of the positive variable. Okay, and we use a squared plus b squared to get the distance between the center and the foci. And the reason we add the two of them together rather than subtract on an ellipse is what? Yeah, because when you add them together, that'll make sure that the foci are outside the box. Okay, and then we use the diagonals as asymptotes to help make the shape of the graph. So we've got to get these into a graph-friendly form. Let's hope neither of these are degenerate. There's something nice about the way this is set up. What is it? Is there anything nice about this one? The variables are on one side. I'll take that. But the variables are on one side here. But we'd need to move that number. Okay? Yeah. Okay, that's it. In order to put these in graph-friendly form, you have to have perfect squares with both x and with y. And these are already written as perfect squares. So we're all set to go. All we need to do is turn that into a 1. So if I go through and I divide everything by 4, that gives me y squared over 4 minus x squared over 1 equals 1. And then I know that this has a center at the origin. And then I go in the y direction, I go 2 units. So I'm going to go up 2 and I'm going to go down 2. And in the x direction, I'm going to go 1. So I've got a fundamental rectangle that looks like this. Okay, and again, hopefully the asymptotes aren't too terribly hard to write. This would be y equals plus or minus. Then I just need a rise and a run and put that in front of x. Again, grab the stuff with the y, put it right there. Grab the expression with the x, put it right there. And all I need is a rise and a run. And which variable is associated with the rise? The y is. So you take the square root of that number, put it over the square root of this number right here. So that would be 2 over 1. So I get y equals plus or minus 2x. There are the asymptotes. I'm going to go ahead and draw those in. And you can tell that those are right because they both go through the origin. They both have a y-intercept of 0. And one has a slope of positive 2. The other one has a slope of negative 2. Okay? Which way does this open? Opens up and down. Okay? So I'm going to put a big point right here and a big point right there. I run along that right here, start curving around so I touch that and then go back up. If it looks horrible, we just erase and try again. Arrows on the ends, comes in like this, goes like that. So I've got a vertex here and a vertex here. I've got a center here. And then I've got foci. Where are the foci? Outside the rectangle, inside the curved part of the conic section. So we're expecting one up here and one down here. Okay, we add the two of these together, so that's going to be 4 plus 1 equals c squared, so that means c equals radical 5. So it's just a little bit more than 2 in each one of those directions. So I've got a focus there and a focus there. And then I'd want to go through and I'd want to label each of those points. Every one of these has an x coordinate of 0. That was 0, 0. Remember, we went up 2 and down 2. And then this one we went up radical 5, and on this one we went down radical 5. And so even if your points don't look great, as long as you've labeled it correctly, you should be in business. Okay, any questions there? So Was number 15 set up like these right here?
Yeah.
Okay, so when you went through, you completed the square and you got a 0 over there. So it was a degenerate conic section. And what does that turn into? Do you remember? Usually just a single point. Okay, single point are two lines that just cross each other. Okay, you won't run into those very often, so don't worry about those too much. Let's take a look at this one right here. We want to go ahead and complete the square. So I'm going to blow this up just a little bit. I'm going to write the stuff with the x first. Save room to complete the square. I'm going to take out a negative while I'm at it. Okay. And that's going to leave me with a plus 4y, and then that equals, if I move the 9 over to the other side, it equals 9. Let's just double check and make sure I got that right. I've got the x squared, the minus 4x. I took out a negative, so I've got one negative out front, and then I've got the y squared. This was negative 4, but if I pulled out the negative, that gives me a positive 4y, and then I can complete the square. Isn't that right, Brandon? What do I do next? Yes, I.
You have to add the number after you complete the square, like you have to do the half of the 4, which is a 2.
I'm going to write a negative 2, and then I. Okay. And then what do I do over here?
You do half of 4, which is 2. Oh no, you add 4.
Okay, we're slowly catching up here, aren't we? Okay. Was your brain somewhere else there for a while?
Yeah.
Okay. What do I do right here?
Half of 4.
Okay, so I get a positive 2. What do I put right here?
4, 2.
If you guess enough numbers, eventually, on a problem like this, you might get it right. Okay, when I put that number right here, I said you should always think or do something on your paper to make sure you get this right.
Do the line.
Okay, because I added 4 inside the parentheses, but there's a negative sitting outside, so really what did I do to this side? I really subtracted 4, so how do I compensate on the other side? I subtract 4 also. So here's what we get. This is going to be x minus 2 quantity squared. This is going to be minus y plus 2 quantity squared, and over on this side we get a 9, okay? Now what do I do next, Brandon? Cameron's cheering you, by the way. I don't know if you saw that. What do we do next?
Wait, can we graph it now?
You could try and graph it, but it's not quite in graph-friendly form yet. So what would we do?
You have to divide it by 9.
Okay, we want to get a 1 over here, so we're going to divide every term on this by 9. So here's what I get. I get x minus 2 quantity squared over 9. I get y plus 2 quantity squared over 9, and over here I get a 1. So where is the center, Brandon? 2, negative 2. So 2, negative 2. There's the center, okay? How far do I go in each direction to make the fundamental rectangle? I go 3. Now what's unique about that for this problem?
It's a square.
It's actually a square. Is that a problem? Nope. Not a problem. Okay? Don't listen to the supreme ruler on your right. Okay, it's not a problem. It doesn't happen very often that these end up being the same. And then really the issue that we run into is on an ellipse, this is no big deal. We talked about how an ellipse can be treated, or a circle can be treated like an ellipse. On this one right here, if this were an ellipse, we'd just be drawing a circle. But on this one, this kind of goes to show when you're graphing these, when we throw all these together, which you will have in 1050, all of these will appear on one single test. You'll have to look at it and you'll have to know what to do with this. The problem here is, which way does this open? And when you've got all of these floating around, like, how do you tell which way a parabola opens? It's which variable is squared and the sign. If y is squared, which way does it open? Left and right for a parabola. If it's negative, it opens left. If it's positive, it opens right. If x is squared, it's either opens up or down. Okay? there's no direction of opening. There's a direction of major and minor axis on an ellipse. And on this one right here, the way we tell whether we're going to draw it up and down or right and left is positive variable. Which one's positive? The x is. So if the x is positive, that means we're going to have a vertex here and a vertex here. So it's going to run along that asymptote, hit this point right here, curve around and head off in that direction right there. So there's a vertex. We're going to do the same thing over here, run along here. Okay, kind of come in and hit that, kind of level off there or get really close to that for just a second. And I've got a vertex here, and right there is the center. And then I need to know where the foci are. And for that, I would add the two of these together. That's going to be 18, and I take the square root. So that means C is 3 radical 2. Square root of 18 is a little bit more than 4, so we'd put 1, 1, 2, 3, 4. So about right there, and about right there. And then we'd want to label each one of those. So this was 2, negative 2. I went over 3 more, so this would be 5, negative 2. And the way I got from here out to here is I added 3 radical 2 to the x coordinate. So this is 2 plus 3 radical 2 comma negative 2. You'll notice that each one of those y coordinates, they're all the same. So this is negative 1, negative 2, and this would be 2 minus 3 radical 2 comma negative 2. There are all 5 of those points. This is a decent looking graph. I've got all the points labeled. What do I not have, Brandon?
You do not have, I don't know.
One more important part to a hyperbola. Starts with A.
Asymptotes.
Very good. Okay. So for that, we make it pretty easy. We grab the expression with the y. So this is going to be y plus 2 equals. We put a plus or minus. And then we grab the expression with the x. This is an x minus 2. And all I need here is I need a rise over a run. Rise comes from the number underneath the y. So that's going to be square root of 9. So that's a 3. Underneath the x is a 9. So square root of that is 3. What do I put right here? I could put a 3 over 3, but I'm going to end up simplifying that. So there are asymptotes. Okay, any questions? Pretty easy? Okay, did you have some problems like this? Okay, tell you what, here's what we're gonna do. We got 35 minutes left. We're gonna take a look at these problems right here. If you'll follow along, I'll shorten the assignment by quite a bit, and then we'll call it good. Okay? All right? Okay, so on this problem right here, it says find the equation. It doesn't say graph it, it just says find the equation. So the center is at 0, 0. Focus is at negative 3, 0. So I've got a center here and then a focus at negative 3, 0. So I've got a focus right there. Which variable is positive? X has got to be positive, because if the focus is over here and the center's right there, it's got to go something like that. And then there'd be another branch over here. Okay, there's got to be a focus over there as well. So if the center is 0, 0, that's going to be x squared, y squared. Got to have the numbers that go underneath each one of those. And it says one vertex is at 2, 0. So that means, gosh, that looks about right. How do I use that information to figure out what these numbers are? So there's the information I've got. I need this number right here, and I need this number right here. Guaranteed you'll have problems like this on a test in Math 1050. Hop. 4 goes underneath the x. Can you tell us why? Okay, so if that's a vertex, we have to go 2 units from the center to get to the vertex, and we go that far in the x direction. So if that's 2, we square that, put that underneath here. So I've got a 4 underneath there, so that's good. So all I need left is just this number right here. Brandon.
4.
Why 4?
Or, no. Yes, I don't know. Yes, it's 4. No, it's not 4.
It's 5.
Cameron, would you help him out? Why is it 5?
Because it could be the a squared plus b squared, c squared thing.
Okay.
And since the focus is at 3 units away from the center, then squared equals 9.
Okay, so I take that number plus the number that goes underneath that one, and it should equal c squared. C is the distance from the center to a focus, so since that's 3, this is going to be 9. So if I move that to the other side, I get b squared equals 5. Do I need to take the square root? No, because it didn't say graph it. We don't have to use it for anything other than writing down the equation, and there it is. Okay? Any questions? Okay. This next one's much more interesting. I'm going to give you a minute to look at that yourself. Okay. It tells you where the foci are, which is a huge a couple of pieces of information. It tells you where both of them are. Okay. And then it tells you what one of the asymptotes is. You should at least be able to get to that point where we know which variable is positive and which one's negative. So you should at least be able to get to the point where you're just missing those two numbers right there. And then you have to think a little bit on this one to figure out what those numbers are. Jordan, which one's positive, x or y? Y is, okay. And what's the center?
0, 0.
So I've got a y squared first over something, and then an x squared over something equals 1. Got to be able to get there, okay? Now, the hard part about this right here is, what's the slope of this asymptote? Okay, so the slope is -1. There are a whole bunch of ways to make -1, okay? You could do a 3 over a 3 like we saw earlier. You could do a 4 over a 4. You could do a 1 over a 1. There are a whole bunch of different numbers that could go underneath x and y that would make that work out to be 1. They just have to be the same number, right? So how do you figure out what it is? Yeah.
Would you draw your asymptote and then figure out like the rise and the run?
Okay, we can draw the asymptotes. So the asymptotes, they're going to look like this, right? Perfect 45 in, perfect 45 out, something like that. Okay, but do I draw the box this big? Do I draw it this big? Do I draw it this big? Do I draw it this big? Certainly wouldn't be the last two, would it? Why not? Why can't it be this one right here? Yeah, too big. Same thing with this one right here. So it's got to be something smaller, but how small is it? No.
Don't you figure it out from the foci?
You do? Okay. How?
Um,
Does anybody know what? No, he's right. You do figure it out using the foci. Okay. Does anybody know how to do it?
I think so. Since A and B are the same, it's just 2a squared equals c squared.
Okay. So normally it's a squared plus b squared equals c squared. Now, do we know what c is? From the center we went up 2 and down 2. So this is going to be a 2, right? So this is going to be a squared plus b squared equals 4. And Jordan, what do we know about the two of these? They're both the same. So instead of having an a squared and a b squared, let's make them both a squared. And then I've got 2a squared equals 4. Move that over to the other side by division. That means I get a squared equals 2. And I don't need the square root of 2 because it didn't say graph it. It didn't say actually draw the asymptotes and stuff like that. I just need a 2 under here and a 2 under there. And there we go. Okay? Some good thinking skills involved there. Okay, any questions? Okay. Let's see. You can do these no problem, right? These are easy? Okay. Let's look at the next page. You already did the graphing ones where you match those up. Find the equation of the hyperbola given the following pieces of information. Okay? Let's go ahead and do these. Centers -3, -4, one focus at -3, -8, and one vertex at -3, -2. Now, you don't have to draw this, but a lot of times it can be helpful. So if we're at -3, -4, so there's the center. Focus at -3, -8. Automatically, what do we know? Y is positive, because it's going to open in the Y direction, because it's going to have to go like this and like that. What do I write? Y plus 4, quantity squared over something, minus, Brandon, you're my favorite today. X plus 3, very good. Okay, and again, like we said several times, it's important to keep track of not only the order these are in, but the order those are in, so that you match them up correctly. H is always with the X, so it's going to go in this second one right here because we're going to put the positive variable first. Okay, and then we just need to figure out what numbers go underneath each one of these. Let's see. We use those two pieces of information. It says there's a vertex at 3, -2. 3, -2. There's a vertex right there. If there's a vertex at -3, -2, where is there another vertex? Yep, -3, -6. Okay, there's got to be one right there. Okay, so how far is it from the center to a vertex? 2 units, right? And that's in the vertical direction, so we're going to put that underneath here. So we're going to square the 2. So that's going to be a 4. And then we just need this one right here. And we know that if this is 2, so that distance right there is 2, and this distance right here is 4, we know we're going to have 2 squared plus b squared equals 4 squared. A squared plus b squared equals c squared. Okay? And then you can find that last one. So that's going to be a 12, isn't it? Okay, I'm going to give you a couple minutes to do part B. Part B is very similar to the one we did just a second ago. It's a little more difficult. See if you can figure that one out. I'll give you 2 or 3 minutes. Okay, for this picture right here, we know x has got to be positive. So the cool part about this is, let's kind of work this backwards. See this stuff with the x right here? That has to be the expression that was squared with the x. And this expression with the y plus 1 quantity squared over 2, equals 1. That's got to be what we have there. And if you stop and think about this, if I've got a vertex here and a vertex here, that means that the center has to be right there. The center's got to be at 1, -1, which means we'd do x minus 1 quantity squared, and we'd do y plus 1 quantity squared, and that's the way it works out there. Okay? In the x direction, I go 2 units, so that's going to be a 4. And then I find this last one. Let's see. How do I find that last one? How do I find what goes underneath there? Yeah. Yeah. On this one, it works out really nicely because underneath the x is a 4. Take the square root, that would be a 2. That means whatever number was up on top, whatever the rise was, that had to be the exact number. This wasn't a reduced fraction or anything. So what goes underneath here? 9. End of story. That easy. Okay? Any questions? Okay. Let's see. 0 plus and minus 3. Those are vertices. So we know y's got to be positive. And we went 3 units, so that's got to be a 9. Easy enough, right? We've done that several times. This one's a little bit more complicated, but we can figure it out here. Or is it? It's pretty easy, isn't it? The number that we take the square root of this, that would go on the top for the rise. So that would be a 3. And what's the number on the bottom? A 1. Okay, now what if this had been y equals plus or minus 6x? Okay, that doesn't change the fact that this number, take the square root, that's a 3. So I put a 3 right here, right? I don't know what the number is right here, but when I simplify the fraction, it's got to turn out to be a 6. So what number has to go right here? It's got to be a half. Okay, so we'd square that, and the number underneath here would be a 4th. Make sense? Wouldn't happen very often, but that would be a good thing to think your way through. Okay, let's see. Would you do the last one, and then that's it? Center's got to be at 0, 1, right? And which variable's got to be positive? X. So it's got to be x squared over something and then y minus 1 squared over something equals 1. And then how do I use this right here? Do you have anything else I had to write down? A 4 underneath the x. Okay, so then the only thing missing is this number right here. And how do I use that? Plug it in. So this would be, if I plug in a 5, that's 25 over 4. If I plug in a 4, that's going to be 9 over b squared, and that equals 1, right? Okay. Always good to practice working with fractions, so go ahead and solve that. In fact, on the calculus exam that the college gave a couple weeks ago, there was an ellipse. It wasn't a hyperbola, but it was an ellipse, and it had something like that, and the students had to do some solving algebraically, and this turned out to be a pain in the butt for them. A lot of people couldn't do it. Not exactly like this, but something similar. Is this right so far? Can I make both sides positive? Can I just do this? Is that okay? Totally all right, isn't it? Okay. If I take one fraction on one side and flip it over, if it equals another fraction on the other side, it should be the same thing when I flip those over. So then all I'm going to do is multiply this side by 9, and I end up with b squared equals, this would be 36 over 21. I could reduce that a little bit. I can write this as 12 over 7. Is that right? And then I don't need to take the square root or anything. This is just going to be 12 over 7. Now, you can write your answer like that. You could, occasionally you'd see something like this, x squared over 4, and then you'll see 7 and 12, and then y minus 1 quantity squared equals 1. Okay? Why would this maybe be a bad idea? Even though it looks better because it doesn't have a fraction in the denominator. Brandon, why would this be a bad idea?
It was 12, not 7 months. Like,
Yeah, they might think that in the y direction you're going to go the square root of 12. When you shouldn't, you should actually go the square root of 12 sevenths. Okay. Good? Okay. All right. So here's what I want